there is a number that has stood for 56 years. 248,655 miles. That is how far the Apollo 13 crew traveled from Earth in April 1970. Not by choice, but because an oxygen tank exploded in their service module, and the mathematics of orbital mechanics dictated that the fastest way home was to go around the moon first. They did not plan to set a record. They were trying not to die. And in doing so, they traveled farther from Earth than any human beings before or since, until April 6th, 2026. At 12:56 p.m. Central Time, the Orion spacecraft carrying NASA astronauts Reed Wiseman, Victor Glover, Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen crossed the 248,655 mile mark. The record held for 56 years, set in a crisis, broken in a mission. By the time Orion reached its farthest point, the crew was 252,756 miles from home. In total, they flew 694,481 miles across 10 days, farther than any humans have ever traveled, at speeds that would cross the continental United States in less than 4 minutes. The Aegis has been modified for this mission in a way that the engineering team described with unusual precision. Not upgraded, not enhanced, calibrated. The suit that has survived neutron star magnetic fields, Venusian acid clouds, and the plasma of the Big Bang has been reconfigured for a threat that is not heat, not pressure, not gravity, but something quieter and more insidious. Distance. Not distance as an inconvenience. Distance as a physical condition. Distance as the thing that determines what protects you, what kills you, and what the universe is willing to do to a human body when there is nothing standing between that body and the full violence of interstellar space. The suit will go where Artemis 2 went, 252,756 miles from Earth, beyond the magnetosphere, beyond the protection, beyond every record ever set by a human being. Could you survive what Artemis 2 survived? You are leaving something you have never thought about. The magnetosphere. It is not visible. It has no color, no texture, no boundary you can see through a window. It is a magnetic field generated by the convection of liquid iron in Earth's core. A planetary force field, roughly 65,000 kilometers tall on the sunward side, and stretching 6 million kilometers on the night side, shaped by the solar wind into something resembling a comet tail. You have lived inside it your entire life. Every human being who has ever existed lived inside it, with exactly 2 exceptions. The 24 Apollo astronauts who left Earth orbit between 1968 and 1972, and the Artemis 2 crew. The International Space Station is inside it. It orbits at roughly 250 miles altitude, comfortably within the magnetosphere's protection, which is why ISS astronauts can stay for 6 months at a time without the radiation exposure becoming immediately catastrophic. Artemis 2 left it entirely. The suit's instruments register the crossing as a transition in particle density, the charged particles that the magnetosphere deflects or traps thinning out, the deep space baseline asserting itself. No alarm, no dramatic moment. The universe does not announce when you are no longer protected. One side of that invisible line, Earth's magnetic field, standing between you and the full spectrum of what space does to human tissue. The other side, nothing between you and everything. The crossing took approximately 30 minutes. The crew covered it at 17,500 miles per hour, which is fast enough that the magnetosphere's thickness, measured in hundreds of thousands of kilometers, felt like passing through a doorway. And then they were outside. For the first time since December 1972, human beings were in deep space. The suit's particle detectors register 3 simultaneous threats the moment the magnetosphere boundary is crossed. The first is the Van Allen belts, 2 regions of intense radiation encircling Earth at altitudes between 1,000 and 60,000 kilometers, where Earth's magnetic field traps protons and electrons from the solar wind. Orion passed through them on the way out, and would pass through them again on the way back. The exposure is intense, but brief, measured in minutes. The suit handles it the same way it handles the approach to a neutron star's magnetic field. Active monitoring, passive shielding, calculated tolerance. The belts are not the primary concern. The second threat is solar energetic particles. Charged particles accelerated to near light speed during solar flares and coronal mass ejections. These events are partially predictable. NASA maintains a space weather forecasting operation specifically for this purpose. For Artemis 2, mission timing was chosen to minimize solar particle event risk, but minimizing is not eliminating. The Sun is not cooperative with launch schedules. If a major solar particle event occurred during the mission, the crew had a designated shelter area inside Orion, a region with additional shielding where they could reduce exposure while waiting for the storm to pass. This is the deep space equivalent of a storm shelter. Effective, cramped, a reminder that the protection available to a human body at 252,000 miles from Earth is measured in centimeters of material and the quality of the forecast. The third threat is the one that cannot be sheltered against. Galactic cosmic rays. These are not solar. They are not local. They are atomic nuclei, mostly protons, but also heavier elements, iron, silicon, carbon, expelled by supernovas and other violent astrophysical events across the galaxy, traveling at fractions of the speed of light, present everywhere in interstellar space, all the time, in all directions. They carry energies that dwarf anything produced by particle accelerators, and they cannot be effectively shielded. Here is the counterintuitive truth that the engineering team had to account for. Adding more shielding to the spacecraft makes galactic cosmic ray exposure worse. When a cosmic ray traveling at 99% of light speed hits a spacecraft wall, it does not simply stop. It causes a cascade, a spray of secondary particles that can be more biologically damaging than the original cosmic ray. The shielding that stops a solar particle event becomes a secondary particle generator against galactic cosmic rays. The only protection against galactic cosmic rays is time. Spend less time in deep space, which is exactly what Artemis 2 did. 10 days, a flyby, a return. Not a landing, not a stay. A visit, carefully timed, carefully measured. Over those 10 days, each Artemis 2 crew member accumulated approximately 12 millisieverts of radiation exposure. For comparison, the average American receives about 6.2 millisieverts per year from all natural background sources combined. The Artemis II crew received nearly 2 years' worth of Earth surface radiation in 10 days, and that was considered acceptable. That was the good outcome, the planned outcome, the outcome that confirmed the mission could be done without immediate harm. The suit's instruments record every millisievert, every particle, every hit. The data will take years to fully analyze. What it already shows is this: the human body, at 252,000 miles from Earth, is operating in an environment it was not built for, protected by a spacecraft it was not designed to inhabit long-term, and absorbing damage that will not fully manifest for years. This is what survival looks like at the record distance. At maximum distance, the instruments record a number that has no intuitive reference point: 252,756 miles. The circumference of the Earth is approximately 24,900 miles. The Artemis II crew was 10 Earth circumferences from home. Light, which crosses the entire continental United States in a fraction of a millisecond, takes 1.4 seconds to travel from Earth to their position. A radio signal takes 1.4 seconds each way. A conversation has a 3-second minimum delay total. A question and its answer, 6 seconds at the speed of light. At that distance, Earth is not a planet you can see as a planet. It is a bright disk in the window, recognizable, blue-green, beautiful, and coverable with a thumb held at arm's length. The crew covered it with a thumb. The psychological implications of this are not theoretical. They have been studied since the first astronauts reported them in the 1960s and have been consistently observed in every long-duration spaceflight mission since. The phenomenon has a name: the overview effect. It is the cognitive shift that occurs when a human being sees Earth as an object in space rather than a world they inhabit. Most astronauts describe it as profound, a sudden, visceral understanding of Earth's fragility, of the arbitrariness of borders and conflict, of the preciousness of the atmosphere, of the fact that everything humanity has ever done or built or loved exists in a thin shell on the surface of one specific rock. At 252,000 miles, the overview effect is not a perspective shift. It is the plain geometric truth. You can cover it with a thumb. Everything is there. You are not. The suit's psychological monitoring systems, biomarkers, cortisol levels, sleep architecture, record what happens to a human nervous system when home is coverable with a thumb. The data will inform every future long-duration mission. Mars is a minimum 6-month transit each way. The psychological profile of a human body at 252,000 miles is the opening data point in a data set that needs to reach 140 million miles. Artemis II was not just a record, it was a calibration. At closest approach, Orion passed within 4,067 miles of the lunar surface. Not on it, past it, swinging around the near side, through the darkness of the far side, and back. The lunar flyby that gave the mission its trajectory and its name. The far side of the moon is not dark. That is a common misconception. The far side receives as much sunlight as the near side, just never faces Earth. What it lacks is visibility from Earth. No telescope has ever seen it directly. No radio signal from Earth reaches it. It is the most consistently radio-quiet region accessible to human spacecraft. a silence so complete that China specifically landed its Chang'e 4 mission there in 2019 because the absence of Earth's radio interference makes it ideal for radio astronomy. The Artemis 2 crew saw it with human eyes. The crew members were the first humans to observe parts of the far side that are not visible from Earth. Not even the oblique, partial glimpses possible during lunar libration, the slight wobble that allows Earth-based observers to see small slivers of the far side over time. They saw craters that no human being had seen directly. They had approximately 7 hours to observe and photograph the lunar surface during the flyby. During the crossing behind the moon, Orion went into a planned communications blackout lasting approximately 40 minutes. The Deep Space Network, the global array of large radio antennas that provides NASA's link to deep space, lost contact. Not because anything went wrong, because the moon was between the spacecraft and Earth, and radio signals do not pass through rock. For 40 minutes, the 4 crew members were completely alone. Not the way astronauts at the International Space Station are sometimes out of contact for minutes. Not the way early Apollo crews lost contact briefly. 40 minutes. Behind the moon. 252,000 miles from Earth, with no signal in and no signal out. When Orion emerged from behind the moon, the crew witnessed an Earthrise, the same phenomenon that William Anders photographed from Apollo 8 in 1968, one of the most reproduced images in human history. Earth rising above the lunar horizon, the familiar blue marble emerging from behind a world with no air, no life, no color, except the gray of ancient rock and the black of space. The suit's cameras captured it. So did the crew. Then, as the spacecraft, the moon, and the sun aligned, the crew witnessed a solar eclipse lasting nearly an hour. Earth's moon blocking Earth's sun, the solar corona visible around the moon's edge as a faint, luminous halo. And, unexpected, Mars, visible in the same frame, aligned with the planetary train. 4 humans, farther from Earth than any humans had ever been, watching an eclipse from a position no human had occupied before, with Mars in the background. The next destination, the one that will require staying far longer and going much farther, watching from 252,000 miles away. The suit's biomedical systems run continuously. They run because what happens to a human body in deep space is not fully understood. The Apollo program provided the first data. The Artemis 2 mission provided the first data in 54 years, under controlled conditions, with modern instrumentation from 4 crew members instead of the Apollo 13 crew's harried emergency return. The data is preliminary. The analysis will take years, but the physical realities are already known. Beyond Earth's magnetosphere, the immune system shifts. Virus reactivation rates increase. The same latent viruses that the immune system suppresses indefinitely on Earth become measurably more active in deep space. Not severely, not acutely, but measurably. The stress of the environment, the radiation, the disrupted sleep architecture from the absence of a natural light cycle, all of it affects the immune system in ways that short missions tolerate and long missions must manage. The cardiovascular system shifts. In microgravity, blood redistributes toward the head and thorax. The heart shrinks slightly. It does not need to pump as hard against gravity's pull. Fluid pressure in the skull increases. Vision can change. Some long-duration astronauts return from the ISS with permanently altered eyesight due to changes in intracranial pressure. Artemis 2 was 10 days. These effects are manageable over 10 days. Mars is 3 years round trip at current propulsion technology. The data from Artemis 2, the radiation measurements, the immune system data, the biomarker analysis, will inform the shielding designs, the pharmaceutical countermeasures, the mission architecture for a mission that is 6 times longer and 40 times farther. The Artemis 2 crew was not just testing whether Orion could fly. They were testing whether a human body could be sustained at the first step towards somewhere much more distant. The suit held, the crew held. The data will tell the next mission what that cost. The reentry was not gentle. Orion hit Earth's upper atmosphere at 24,664 miles per hour. For reference, a rifle bullet travels at approximately 1,700 miles per hour. The Orion capsule, loaded with 4 humans and 10 days of data, was traveling 14 times faster than a rifle bullet when it met the first molecules of air. The heat shield reached temperatures exceeding 5,000 degrees Fahrenheit. The Big Bang tup, the plasma at T equals 1 second, was 10 billion degrees. That is the context. Re-entry, the thing that has killed astronauts and is universally described as one of the most violent phases of spaceflight, was trivial in comparison to the environments this suit has survived. But for an unprotected human body, 5,000 degrees is not trivial. It is the only thing standing between the crew and the physics of a meteorite. Orion used a skip re-entry technique, dipping into the atmosphere, bouncing out slightly, then descending again, that had never been used by a crewed spacecraft at lunar return velocities before. The technique was tested, the data was collected, the models were validated. Splashdown, April 10th, 2026, 5:07 p.m. Pacific Time. Pacific Ocean, off the coast of San Diego. The crew had been 252,756 miles away. They were now floating in saltwater, surrounded by Navy recovery teams, waiting for helicopters. The record stands: 252,756 miles. The farthest any human being has ever been from Earth. Set not in a crisis as Apollo 13's record was, but deliberately, carefully, as the first step in a planned return to deep space. Here is what the record means. It means the gap between Earth and Mars, the 140 million miles that separate the 2 planets at closest approach, the 6 months of transit each way, is no longer purely theoretical for human spaceflight. It has a first data point. It has a radiation measurement. It has a biomarker data set. It has a psychological profile of 4 specific humans in deep space for 10 days. The record was not broken because breaking records is the goal. The record was broken because the goal is Mars, and you cannot go to Mars without first going to the moon. And you cannot go to the moon without first knowing what the moon costs. Artemis 2 answered, "This is what it costs. 12 millisieverts of radiation, 10 days of immune system shift, vision changes under monitoring, a cognitive reorganization called the overview effect. This is the price of 252,000 miles. Mars is 600 times farther. The next crew will need to know, could you survive what Artemis 2 survived?" The crew did, barely unharmed, carefully managed, deliberately monitored, with the best spacecraft ever built for deep space human travel, the best mission planning, the best space weather forecasting, and the full collective knowledge of every space program in history. They went farther than anyone. They came back, and what they left behind is not a record. It is a question. If 10 days costs this much, If the most carefully planned deep space human mission in 50 years produces 12 millisieverts of radiation, measurable immune changes, and a psychological data point about what it does to a human being to see Earth shrink to the size of a thumbnail, what does 3 years cost? We are about to find out. What impossible environment should we face next? Should the Aegis go to the lunar surface, where Artemis 3 will attempt to land humans for the first time since 1972, where the regolith is sharp as glass, the temperature swings 300 degrees between shadow and sunlight, and there is no atmosphere to warn you if your suit tears? Or should we go deeper, to the point of no return, the maximum distance at which Orion's free return trajectory could still bring the crew back to Earth if all propulsion failed? The edge of what was survivable without a working engine. Vote in the comments and subscribe to Could You before the distance wins.